Okay, Algebra 1 students, welcome to part 2 of our combination lesson 12 and 13. So now we have graphed both of our lines. We can see that they cross. That's interesting. So let's go back to the lesson and see what they want you to do. So now they want you to do the same thing that you did for the money, okay? They want you to do the same thing. Oh, sorry. I'm sorry. Oh, no. They do want you to do the same thing. So now they want you to finish this. So you would go to Desmos. You would say, okay, if I didn't buy any raisins, if raisins were 0, remember raisins are X and walnuts are Y. So if I did not buy any raisins, so raisins are 0, walnuts are 2. Okay? So you would put a 2 in your student task statement. Okay? So here's where they say you can graph it on the, so this would be 2. Okay? And you would continue to fill out the table like that. And I know you can do this. So you can go ahead, keep doing that. Go back to Desmos, find the value that you know, either X or Y, go across to the graph, click on that point, and as long as you're close, you'll be fine. Okay, it doesn't have to be exact. So once again, here, where they ask for you to explain your reasoning, you're just going to tell them, how did you know how to fill out this table? Well, how do you fill out a table? You look at a graph, okay? And you get the values from the graph. That's how you're doing it for this activity, okay? So they want you to answer the question. And the question is going to be this point right here. Okay? So Diego bought 0.25 pounds of raisins and 1.75 pounds of walnuts. Okay? So that's what you would put. 0.25, 1.75. Then you would put that in your 0.25 and 1.75. Okay? Alrighty? And how do you know? Because that is where the two lines cross. And if you multiply 0.25 by 4, and if you multiply 1.75 by 8, you will find that the number you get adds up to, those two numbers add up to 15. Okay, you should try it. So I'm not going to go through this entire activity. I'm just going to say. So the third activity in lesson 12 is building. Everything builds on everything else. So now they're just going to give you the two different constraints. Okay? So now they're going to tell you that a dining hall has so many tables. Some are long and rectangular and some are round. Okay? Long tables can seat a certain amount of people and round tables can seat a certain amount of people. And on a particular evening, all 190 seats are occupied. Okay? So, you are going to come up with, first you're going to answer the question, how many of each are there? And then you're going to tell them how you figured that out. You're supposed to do it like a puzzle. And then they're going to give you another situation. Okay? And yet another situation where they're giving you two constraints. And they're asking you to figure out what the answer would be. Okay? Which you can do without algebra. So that's the purpose of this. So now let's get into the summary. So in lesson 12, what was the point they wanted you to get out of this lesson? Okay, Algebra 1 students. So this is how they begin the summary, okay? They're giving you another scenario that they're going to talk about. Here we have a costume designer, and this person needs some silver thread and some gold thread for costumes at a school play. Okay? She needs a total of 240 yards. At a store that sells thread by the yard, silver thread is 4 cents a yard and gold thread is 7 cents a yard. And the designer has $15 to spend on the thread. So once again, so how many of each color should she buy? And they're telling you right here, this situation involves 2 quantities and 2 constraints. Okay? Length. So how many yards of thread are we buying? And how much it cost. Okay? Answering the question means finding a pair of values that meets both constraints simultaneously, which means at the same time. To do so, we can write 2 equations and graph them in the same coordinate plane. And here are the 2. So if we add up the silver thread and the gold thread, we're going to get 240 yards. Okay? And now we're going to do money. So here's the cost of silver thread, the cost per gold thread, and how much money she's going to spend. Okay? So every point on this graph is a pair of values that meets the length constraint. Okay? Every point on this graph is a pair of values that meet the cost constraint. They make the cost equation true. So the point where the 2 graphs intersect gives you the pair of values that meets both constraints. Okay? So that's the purpose of systems of equations. And here is the situation. Okay? You have your length constraint. Okay, 240, 240. If you only bought gold thread, you would have 240 yards, right? If you only bought silver thread, you would have 240 yards. And here is how much it would cost if you only bought gold thread. And this is how much it would cost if you only bought silver thread. Okay? Actually, you can't even see that. You can't see that. But this point right here is this is your combo. Okay? That makes both constraints true. And here they prove it to you, young people. That's the point of this part. Okay? Is you substitute 60 for X and 180 for Y in both equations. You have to do it in both. Do you see? Here's your X plus Y equals 240. 60 plus 180. It does equal 240. That's true. Okay? And here's our cost equation. So 60 times 0.04 and 180 times 0.07 gives you $2.40 plus $12.60, which equals $15. Okay? And then here's the conclusion. 2 or more equations that represent the constraints in the same situation form a system of equations, and they're often grouped together with a curly bracket. And the solution to a system of equations is a pair of values that makes all of the equations in the system true. Okay? And graphing the two equations is one way to solve this situation. Okay? Thank you for participating in this. Thank you for listening. And I'll see you in part 3.